distributions. Okay, so first of all, what is a binomial distribution in statistics? Binomial distribution summarizes the number of trials or observations when each trial has the same probability of attaining one particular value. The binomial distribution determines the probability of observing a specified number of successful outcomes in a specified number of trials. So also, what is the binomial distribution used for? So the binomial distribution model allows us to compute the probability of observing a specified number of successes when the process is repeated a specific number of times and the outcome for a given patient is either a success or a failure. So a lot of people like to use for binomial distribution examples, toss the coin 5 times and what is the chance of getting 3 heads? So that's how you find the probabilities. You use the formula and you get into looking for the chances. All right, so my example that I want to show to you guys is one from throw a die. So a fair die is thrown 4 times. Calculate the probabilities of getting 0 twos, 1 2, 2 twos, 3 twos, and 4 twos. So I'm going to be using the Paint app to show you guys how I did my calculations. So, as you guys know, for binomial, n is always going to equal the number of trials, p is always going to equal the probability, and x is always going to equal the successful outcomes. All right, so for my case, let's go into the paint. All right, for my case, so as you guys know, I'm just going to rewrite it for you guys. We're going to focus on finding 0 twos. I'm sorry if you guys cannot understand my handwriting, but I'm going to be saying it out loud just in case. 1 4 twos. So that's what we are going to be focusing on. And as you guys know, the number of trials is 4. So that means that n is going to be equal to 4, and p, for probabilities, is going to be, p equals p, I'm sorry, that's a p, 2 equals 1, 6. All right, kind of understandable. So once again, 0 twos, 1 2, 2 twos, 3 twos, and 4 twos. And since we're gonna be n equals 4 because that's the number of trials, and p, this is the probability, and we want to focus on 2, so it equals 1/6. All right, let's get into finding our 0 twos. No, first of all, let me show you guys the formula we're going to be using. Sorry, forgot about that. Another page. So our formula we're going to use is P, K, let me say it out loud for you guys, out of N. PK out of N equals N. So N, remember you guys, our N is 4. And K, decimal point, N minus K. And then P, K, n1 minus p to the n minus k power. That's our formula. That's the one we're going to be using. And just so to let you guys know, there are a lot of formulas, but I just want to explain to you guys how it is explained, the binomial formula explained. So the n, this starts the count of number of ways event can occur. This ends the count of number of ways event can occur. This deletes duplications, and this is the probability of failure for the X trials. And this up here, the P this is the probability of success for X trials. And how do you calculate N over K? So to calculate the number of happening of an event, N chooses K tool is used. N is the sum of data, and K is the number that we choose from the sum of data. The formula for N choose K formula is C N K equals N exclamation point and K. All right, let's head on to finding our probabilities. So we're going to be using the paint board. So paint. And I'm going to be saying the numbers out loud just in case you guys don't understand my writing. It's really hard writing on this. All right. So we're going to find our 0, 2's first. All right, so we'll start off with P. P x equals 0, since we're going to be finding that one. Px equals 0 equals 4, so that's our number of trials. 0, so that's what we're focusing on. Finding the 0, 2's. 4 again. Times 1 to the 6. You guys know why we're putting 1 to the 6, right? 0. Then 5 to the 6. 4. We're focusing on the number 4. Equals 1 times 1 times. So let's go on to our calculator on Google to find our probability. All right, so my calculator is right here. As you guys can see, the calculator does everything for you guys. It's very easy. Just insert it as how you have it. 1 times 1 times 5. 5 to the 6 to the 4th power. So we get 0.4822. But we're going to round the 2 that's next to the 5 because it's closer to 3. All right, so it's going to be 0.4823. 0.4823. 23. All right, that's our first probability for 0, 2. That's our first answer. Let's head on to our finding our 1, 2. All right, so P x equals 1 equals 4, our number of trials. 1, we're finding 1. Times to the 6th power 1. And then 5 to the 6th power, 5 over 6 to the 3rd power equals 4 times 1 to the 6th times, this looks so messy, I'm sorry guys, 5 to the 6th to the 3rd power. Oh, I'm so sorry guys. If you guys don't understand, let me say it. So P x equals 1 equals 4 decimal point, fix that, over 1 decimal point and 3 decimal point times 1 to the 6th to the first power, and 5 over 6 to the 3rd power equals 4 times 1 over 6 times 5 over 6 to the 3rd power. So let's head on to our calculator. We will be putting 4 times 1 divided by 6 times 5 divided by 6 over to the 3rd power. We get 0.3858. 0.3858. 0.3858. So that's our second probability. We're closer. We're getting closer to finishing. Next up, we're going to be finding our 2-2. All right, 2-2. Let's get on it. P two Sorry, guys. So 4 decimal over 2 decimal, 2 decimal. Sorry, not decimal, exclamation point. Times 1 over 6 to the 2nd power and 5 over 6 to the 2nd power equals 6 times, that's 6 multiplied by 1 over 6 to the 2nd times 5 over 6 to the 2nd power. So we're going to head on to the calculator to find our probability. So 6 times 1 over 6 to the 2nd power times 5 over 6 to the 2nd power. 6 times 6 to the 2nd power times 5 over 6 to the 2nd power equals 0.1157. 0.1157. 0.1157. That's our second one. Yay! Let's go on to number 3. Finding our 3 2's. Getting close, guys. Okay, so equals 4 exclamation point, 2 exclamation point, 1 exclamation point, sorry guys, times 1 over 6 to the third power, 5 over 6 to the third, equals 4 times 1 over 6 third over 6 to the 0 power, my friend. I know this one's different. 0. 0. All right, let's go on to calculator to find our probability. 4 times 1 over 6 to the third power times 5. Oops. 6 equals 0.0154. So 0.0154. That's our third probability. Now we're going on to the last one. Okay, guys, let's go back to here, finding paint. We are almost done. We will find out all the probabilities. All right, so let's head on to the last one. P, x equals 4 equals 4 decimal point, no, sorry, exclamation point. I don't know why I keep getting confused. 4 exclamation point 0 exclamation times 1 to the 6 over to the fourth power and 5 over 6 to the 0 equals 1 times 1 over 6 to the fourth power equals, sorry, times 1, not equals, sorry guys, times 1. So let me go over it again because I can't, well, honestly, I can't even really understand my handwriting. Probably you guys won't either. So Px equals 4, because we're trying to find the 4 twos, equals 4. That's our number of trials. Exclamation point over 4 exclamation point 0 exclamation point times 1 to the 6 to the 4th and 5 over 6 to the 0 power equals 1 times 1 over 6 to the 4th power times 1. So let's head on to our calculator to find the last probability. We are almost done, guys. 1 times 1 to the 6th power. I mean, it's 1 divided by 6 to the 4th power times 1. We get a total of 0.007. But we're going to round up the 7 since it's closer to 8. So it'll be 0.0007. I mean 8. My pain. Sorry guys, I'm so lost. 0.0008. All right. So we got our 4 probabilities. So this is for the 4 twos, we got 0.008. For our 3 twos, we got 0.0154. For our 2 twos is 0.1157. For our 1 twos is 0.3858. And for our 0 twos, it is 0.4823. All right, so those are our probabilities. Now we're going to head on to graphing it. So we're going to go on to JASP. So I like to use JASP since that's the application my professor showed me. And first of all, I'm going to show you guys the table I did. Where did I put my table? Oh, let me open JASP and I'll show you guys my table. I did it on Excel and I'm going to open it up on JASP. Takes a little while to download. Open a file, recent files, drone die. So this is my data. So right here, I put number and the probability. So 0 twos, 1 2, 2 twos, 3 twos, 4 twos. And these are the probabilities we just got. So I'm going to open up distributions and open up binomial. And as you can see, that graph looks very odd. So since we only focused on 4, finding 4, we're gonna press 4. And then P probability, we had we had 1 over 6, and we're gonna convert it to 1/6 in decimal. Which is 0.116. And then our number of trials was 4. So this is what we get. This is how my graph looks. So right here, when you guys want to graph, when you open it up, there's gonna be very different numbers for probability and number of trials. So you put the probability, which mine was 1 over 6. That's what I used for my P equals P2, which was 1 over 6, and I converted it to decimal, as you guys saw, 0.16. And then I put it on here, and my number of trials is 4. And this is how my graph looks. All right, guys, I hope you guys understood a little bit of my example. I hope this was helpful, and I hope it works out for you guys. Thank you so much for watching.